Please welcome to the stage David Andrew Fink.
Well, thanks. So first I'd like to thank David for the invitation to come. This conference, I've heard about it for a while and it's been high on my list. I heard it's really a great event and it's also in an amazing building. So today I'd like to talk to you about how we work a little bit smarter at Henning Larsen. And I'll take you through some of the projects we've done and some of the work that we've completed in the past. So at Henning Larsen, we see software as the tools of our trade. We don't see them as much different as a craftsman or an artist. We kind of see them, these as our pens and pencils and our saws, our drills, our hammers. And this is what we use to create our projects. And we have designers that have their favorite tools. And we try to also enable them to use the tools in the best possible way. But like a craftsman, the tools that we have don't necessarily do everything we need them to do. So sometimes we have to make a jig to get that perfect cut on a table saw, or find a better way to do something that we want to do a little bit faster. So I found this diagram, and I think this really kind of sums things up really well. We have two people that start a project. One's a geek, one's a non-geek. So the geek starts to do the task with the non-geek. The geek starts to get a little irritated with the process, stops working, thinks about it, tries to develop a script or a way of doing it better, while the non-geek keeps on working, starts to make fun of the geek. Then after a short period of time, the geek has created the script, run the script, completed the task and gone home, while the non-geek is sitting there still doing his work. And I think this is really a good way of describing what we're after, is how can we work a little better, a little smarter, so we can go home on time. And we see this as we have different levels of development in the office. At the very basic, we have the clicker, and that's pretty much analog. It's just using the muscles in your finger to click the mouse and your arm to move it around. Not much automation there. The next level we have is visual programming. And this is kind of the entry point of a lot of our designers and architects in the office, that you work with nodes and wires and can mimic a process in a smarter way. So this is a way how we start to get people into thinking about the process that we use in a better way. Then the next level up from this is scripting, and this is a little bit more complex. We're using tools like Python or C#. And this you need to know some syntax and have a little bit more expertise. And it's kind of the next level up from visual programming. Then from this, we can see that we can take the tools and start to build add-ons in the tools that we use to make the tools we use work a little bit better and a little bit faster. And at the top of this, we have applications, where we have tasks that we want to complete in a way that we can kind of automate them in an independent program that can run by itself. So when we look at the kind of the bottom level of this, we have two levels of people. We have like these citizen developers and we have coders. And our goal is to try and create as many citizen developers in the office. Like, how can we get everyone in the office to just do a little bit of coding or think about the coding process so they can describe it to somebody else so they can build something for them. And we can see in the Danish school systems, they are teaching coding at a very young age, and it's not that difficult. And the two entry points of this are Dynamo and Grasshopper. But even if you do something in Excel, just to kind of make your work processes a little bit easier and a little bit faster, that's okay too, because now you're starting to think of the steps you need to complete a task. And then once we get them into this, then maybe they'll become coders, maybe they'll start to create some more formal scripts, and maybe even eventually they'll start to create some add-ins for us. So when we talk about this visual programming, I'll give a couple examples of this. We do a lot of projects like this. It's a housing project, lots of buildings, lots of apartment types, and one of the deliveries is area calculations. And area calculations are that a piece of the public areas has to be added to each of the apartments in a building. And typically, we've done this manually. We've taken all of the area information out of a project, then we've exported it into Excel. Somebody runs the manual calculations while the rest of the team is drinking coffee to see if we've met the requirements, find out they don't meet, and then they go back to work. So we start working with all this data and visualization in the project, but we want to do this in a smarter way. We want to do this in a way that we can be designing and checking the area calculations on the fly. So is what one of the team members on this project happened to do was think about it as like, okay, if we can outline the steps we need to take to make this calculation. First, we need to calculate all the areas. We need to count up the apartments. We need to total the areas of all public areas, divide the public areas by the number of apartments, add that back into the areas, and write that back to the model. So within a couple of hours, we had created a dynamo graph that could do this calculation automatically. And what the benefit of this is we didn't have to stop the process. All we had to do was click run. But of course, our designers don't want to see the spaghetti diagrams. So we made this even simpler for them. We made this in Dynamo Player. So all they have to do is push a button in Dynamo Player. They don't see anything that's happening in the background. And these calculations calculate automatically. Then we took it also to the next level and started to visualize this data that we were getting out of the project. So from this, the project manager could start to slice and dice the project to find out where the apartments were, how many different apartment types we had, where the areas were we above or below the requirements, and all of this visual. And architects and visualizations are key, because if I give them lots of numbers, they're not going to look at them. If I give them graphs and charts and ways of slicing and dicing the data, then they start to use it. So the next project I'd like to tell you about is this World of Volvo. It's a project we just completed in Gothenburg. And if you're ever in Gothenburg, you have to see this building. It's amazing. I was there over the summer. You have to see it. It's a CLT, or cross-laminated timber project, and it's huge. And when we were early in the design process, one of the designers had an idea that we were going through masses and lots of design iterations of this project. It's like, can we script this so we can easily make design iterations quickly? So he took this project and created a Grasshopper script that basically mimicked the geometry of the project. So this enabled the design team to kind of start to stretch and move the project around with a few sliders in a Grasshopper graph. And then in the end, we had this model that we can actually, just by sliding around in the Grasshopper graph, refine the geometry. But this graph actually lived way beyond the end of the design phase. It was handed off to the fabricator for the wood and the steel, and it was used to generate the geometry of the project for fabrication. And then when it was brought onto site, we had like pretty much a flat pack cross-laminated timber that's had to be hoisted into place. Then when we come up to the next level of scripting, we add another level of complexity, and these are typically tasks that we can't do with visual programming. So the idea is that we use a lot of scripting for calculations for environmental factors on a building, daylighting, microclimate, paths around the building. But we've also decided that we could take this one step further. We can use this data to also turn it around and help us generate the geometry of the project. And this is something you can't quite do with visual programming. It's typically too complex, and visual programming is also a little bit slow. So we had the ability to take this information that we get from our design analyses, turn it around, and find out what the massing of the projects is. And we're not looking at final design solutions, but we're looking at suggestions so we know that the project is moving in the right direction. Then we have this generative design graphs, where basically we can use this programming and a few sliders to kind of control the outcomes and also set up the goals in the project. So we can quickly run through hundreds or thousands of design iterations and develop the best massing of the project. And once again, these aren't the final designs, but it gives us a good head start on the project. Then the next level up from this is add-ins. And we actually haven't designed that many add-ins. The add-ins we've designed are mostly to help our users use the tools we have in the way we want them to use the tools. So we've developed add-ins for both Revit and Rhino. Those are our two primary tools. And what it does is it directs the users to the information we have so they can find answers to the questions that they have or the information they need when they're working on the project. And that's kind of the extent of the add-ins that we've done. And the reason this is because if we look out on the market of all of the add-ins that are available, there's a huge number of add-ins that we can be using. And the benefit of having these off-the-shelf add-ins that we use is that we can go in and we can buy them. They maintain them version to version. When it breaks, we know who to call. And it often offers us the functionality that we need. Like Henning Larsen is now also part of Ramble. They develop a lot of add-ins for their engineering services, and we would like to go the same way in the future, but I think for right now, we've pretty much solved a lot of our issues just by using these off-the-shelf solutions that we can get into the software that we use. So now I'd like to take this up another level to applications. And when we talk about applications, this is something that is not necessarily something that's fit for a specific piece of software, but something that can also bridge multiple pieces of software. And the first application I'd like to tell you about is this GeoPlant. And this GeoPlant is basically a searchable plant database for our landscape architects. And what we've done is we've gone out and we've tried to scrape several plant databases and try to give our landscape architects as much information as they can while we're designing projects. Because right now, we're really after improving the quality of the sites after we leave them. So we look at the biodiversity net gain, and that biodiversity net gain, we always want to be at a higher level than when we start. And what's the best way to start is choosing the right plants for the right sites in the right locations. We're a global office, and it's really important that we have knowledge of what we use in different geographies. So if we want to do a project in Iceland, we can go into this GeoPlant database and pick the plants that we can use in Iceland. Or if we have a project in Saudi Arabia, we can also find the plants there. So right now, we have about 5,600 plants in the database, and they've been scraped for about a little bit more than, I think, 8 sources now. And each plant has about 62 different features. And not all of the features are filled out for every plant, but hopefully in the future, as time goes on, we can add more and more information. And this could be about the water requirements, the size of the plants. Do they bear fruit? What color leaves do they have? Do they keep their leaves in the wintertime? All these different factors that can help our landscape architects make a valid or decision on the plantings that they choose. This next project here, or application, is called Urban Decarb. And this is one of those platforms that works across multiple platforms. So Urban Decarb is a project we're working on, and basically it looks at carbon beyond the footprint of the building. It looks at the carbon in more of an area or a portion of an urban design. So the idea of Urban Decarb is that we have a building or a site that we're designing. We can make some assumptions based on the different construction types. Is it concrete or wood? And then also we can go in and say, what are the surroundings going to be? And it's really this early stage design tool, because I don't need to show you that graph, but you know that you can have the greatest impact at the early stage of design with the least amount of effort. And this is where a tool like this is really important. So basically, we can start with a baseline of the project, just kind of a basic site. We can go out and we can find out what the surrounding buildings' constructions are. We can calculate a rough carbon calculation on that. We can look at the urban context of the site. We can say, okay, what happens if we change a parking garage for a park? What happens if we minimize the amount of concrete paving that we use? We make all of these assumptions and get a final calculation of the carbon impact of this urban design project. And I think this is also where the future is going, because we shouldn't only be looking at the buildings. We need to be looking at the buildings that we design in the context as well. Then this last project is something we've just recently started, and it's called Open Detail. And basically, the idea is, how can we create an open source sustainable detail database? And this started as an idea in our office. We took it to the AEC hackathon in Copenhagen, and it won one of the prizes. And now we're developing the front end and the back end of this tool, and hopefully having it ready in the next couple of weeks. We have some legal issues with it, but we'll get those sorted out over time. But the idea is that we've experimented with several different building material types. We've experimented with cross-laminated timber, hay bales, mud, and multiple other materials, and they require a different set of details. So the idea is, how can we make these details available to others? And if they have interesting details, maybe you have a sustainable method in Iceland that we can add to this database so it can be available for others who are curious about those construction techniques. And a lot of these are old construction techniques, maybe 200 to 500 years old that we're reinventing because we know back then it was a sustainable solution, which means it's a sustainable solution today. We just need to modernize it for the modern building industry. So it's really a valuable tool for us to kind of share our knowledge and also get other people's knowledge as well. Then I'd like to kind of start to end this on AI because everybody is talking about AI. So I thought that it would be a good idea to show you how we use AI right now. We're also looking into the future for additional use cases and finding the best possible way. But we want to do it in the right way in the future. So the first step we're doing is, many of you are also using these large language models. So is what we've done with Ramble, or Ramble has actually done, is created something called RAM-GPT. So it's basically a inward-facing large language model. And this means that we can put project information, documents that shouldn't be made public into this large language model and get the results. So it's a closed system. If we put those documents out into ChatGPT, then they would be made public. So this is more inward-facing, it's more secure, and we have more confidence of using a tool like this. So we can use this for summarizing meetings, for reviewing documents, summarizing documents, writing texts, and it's all based on what we've written in the past within the company. So it's not going out. We're not going to get a document from Big or a C.F. Muller or another architect. This is all going to be Henning, Larsen, and Ramble data that it's based on. And then the next part of this is visualizations. And I think that we've all been looking at how we use visualizations. We've gone out on LinkedIn and we've seen like hundreds of posts of people using Stable Diffusion or Midjourney or all these tools to create visualizations. We've started playing with this as well, but our goal is we want a model that's trained on Henning Larsen projects. So when we run our visualizations, we can get that Henning Larsen feel of the projects. It's not going to look like a Big project or a C.F. Muller project. It's going to look like a Henning Larsen project in the end. And we have started using some of these tools on some projects. We have some projects in Asia where the clients don't look at the plans. They only look at visualizations, and they want hundreds of visualizations. And the only way we can achieve that is with AI visualizations. And it works really well, and it gives us a pretty good impression of the projects. So, but where do we see AI going? And I think there's been a lot of talk that AI is going to take our jobs away. And I think at Henning Larsen, we don't see it that way. We kind of see AI as the new tool in our toolbox that is going to make us work a little bit smarter, a little bit faster, and a little bit better. And I was at a conference a couple of weeks ago, and I had also seen this posted online previously. And I think this is perfect. The way it describes the use of AI is I want AI to do my laundry and dishes so that I can do my art and writing. Not for AI to do my art and writing, so I can do my laundry and dishes. And I think this is really true. We don't want AI to take like the creative aspects of it, the humanistic aspects of our work away. We want it to help us work a little smarter and a little bit better so we can get better results and how we can apply that into our projects as well. So I don't want AI to take all the fun work away. I want AI to begin to help me do the work I do a little bit better and a little bit faster. So with all these tools that I've shown you today, we kind of see this as how can we augment our architects and designers and building constructors to work a little bit smarter and a little bit better and give them the right tools they need at their fingertips so they can also go home on time. And I think with all of these tools, like we have an idea at Henning Larsen, and the idea is that it's architecture first. We want the designs to come out the way we want the designs to come out. And we don't want to make sacrifices because the software couldn't do something. If the software doesn't work, we'll find a way to make it work for us. So it's really about how do we work with the tools that we have and get the results that we want. So I think that pretty much concludes what I had to tell you about how we work at Henning Larsen. And I think I don't know if I have a couple of minutes for questions or we need to move on.
Yeah, we have. We might have time for a question. Thank you so much for a great presentation. And as I mentioned before, you probably have a reputation of working quite smart already at a Danish architecture firm, but working even smarter now. So maybe just a general question about your final note about AI. How do you expect AI to be used in design and construction in the future?
Yeah, I think it's going to help us make better and more informed decisions. And I think it's also going to help us plan the work that we do much better and in a much more effective way. Because I don't think it's going to kind of take away those tasks of designing a building. It's going to help us design a better building in the end.
But do you dread at all that like the spontaneous nature of designing might disappear with all these smart decisions and planning?
I'm kind of worried that it's going to go even faster because now we can get even more results faster than we could before.
Right.
All that research time is at our fingertips.
Right. Yeah, and maybe going back to that final quote, the one you draw from X or Twitter, maybe we have some more wiggle room to be spontaneous and creative if we let AI do all the tedious work.
Yeah, I think it's really making AI do the heavy lifting so we can go home on time and we can design better projects.
Right. Perfect. Well, thank you so much, David, and please give him a round of applause. Thank you so much.
Thanks.